this problem, a matrix A is given as 0, alpha, beta and 0, and is asking what will be the condition if a cube plus a is equals to 0. Now we know that a cube plus a is 0, so I'll write it as a cube is equals to minus I. Multiply a inverse on both sides, so it will be a square is equals to minus I. Now let us find out a square. 0 alpha beta 0, 0 alpha beta and 0. Now if I multiply, it will be alpha beta, then 0 alpha beta. Now this is nothing but a square, and which is equals to minus I, which is minus 1 0 0 minus 1. So clearly alpha beta must be equals to minus 1, which is option D. Problem, we have to find the limit of integral y to a e power sin square t dt plus a to x plus y e power sin square t dt by x. Now as the limit is from y to a and a to x plus y, I can write it as y to x plus y. So this can be written as limit extends to 0, integral over y to x plus y e power sin square t into dt by x. Now in order to find the limit of this expression, what I do is I'll use L'Hospital's rule. L'Hospital's rule. So we'll differentiate numerator and denominator separately. Differentiation of a to b f of x dx is nothing but f of b into f dash of b minus f of a into f dash of a. So here b is nothing but x plus y, a is nothing but y. So if I substitute that value, it will be f of b is nothing but e power sin square of x plus y into differentiation of b. Differentiation of x plus y is 1 plus 0 minus differentiation f of a will be e power sin square y, and differentiation of y is nothing but 0 by differentiation of x is 1. So limit x is tending to 0. So I can write this as limit x tends to 0 e power sin square of x plus y. Now as x is tending to 0, this will be e power sin square y, which is nothing but option A. This problem, it is given that a die has 4 blank faces and 2 faces marked as 3. So a die consists of 4 blank faces, only 2 faces are considered marked as 3. Now he's asking, if it is thrown for 5 times, what is the probability that you'll get 12? Now we will get 12 if out of 5 throws, exactly 4 throws are 3s. So and 5th throw must not be 3, so it should be blank. So exactly 4, it is nothing but p of x is equals to 4. We'll use binomial theorem here, and the number of throws here are 5. See, and what do we need? We need exactly 4, and the probability of getting a 3 is nothing but 2 chances out of 6 chances raised to the power of 4 into, and not getting is nothing but 4 chances out of 6 chances, and if you simplify, it will be 5c4 into 1 by 3 raised to the power of 4 into 2 by 3, which is nothing but option A.
Question is, find the Laplace transform of a system that is sin 2t cos 2t. Here if we multiply the input signal, that is signal by 2, and divide it by 2, sin 2t cos 2t, we can write it as sin 4t. So if we apply the Laplace transform to this signal, 1 by 2 4 divided by s square 16, which is nothing but 2 by s square plus 16. That is nothing but option C is correct.
So we have to find the approximation of x square minus 1 by x square plus 1, whereas h is given as 0.2 between the ordinates x is equal to 1 and x is equal to 2. If you substitute these values, what are the ordinates you'll get? Now let us prepare the table here. X values I'll start from 1, then there will be a difference of 0.2, so it will be 1.2, then x2 is equals to 1.4, x3 is nothing but 1.6, x4 is 1.8, x5 is 2, x6 is 2.2, x7 is nothing but 2.4, x8 is nothing but 2.6, x9 is equals to 2.8, and the corresponding values of y, if I substitute x values, it will be 0.18, 0.32, 0.43, 0.52, 0.6, then it comes 0.65, 0.70, 0.74 and 0.77. Now we have to find the, we have to evaluate the value between the limits x1 and x2 f of x dx. Now 3/8 rule is 3 by 8 times of h first term plus last term plus 3 times of y1 plus y2 plus y3 plus y4 plus y5 plus y7 plus y8. That means the suffixes of 3 must not be there. Multiples of 3 should not be there in the suffixes. So plus 2 times of y3 plus y6. If I substitute all the values and simplify, answer will be 0.9152, which is nothing but A.
Is Fourier transform of the signal e power a mod t. So we can write e power minus a mod t as e power minus at u of t plus e power at u of minus t. Okay, so for this one a plus j omega, for this one this is going to be minus 1 by a minus j omega. So if we simplify this one, we will get 2a by a square plus omega square. Hence option C is correct. The Z transform of a signal a and u of n is, here a and u of n, if we apply a Z transform, we will get z by z minus a, which is nothing but 1 by 1 a z inverse, which is option C is correct. A system is described by the difference equation y of n equals to x of n minus x of n minus 3 plus x of n minus 5 minus x of n minus 7. The impulse response of the system is, here y of n is nothing but h of n convolved with x of n. So with the help of this property, h of n is nothing but delta of n minus delta of n minus 3 plus delta of n minus 5 minus delta of n minus 7. Hence option B is correct. Question is, the determinant of matrix A is 0, then the value of x is. Here the det of A is nothing but x square minus 1, which is 0 from the given data. So x square is x is under root 1, which is plus or minus 1. Hence option D is correct. The determinant matrix of a system is shown below. Find its KCL equation. Here these are the node numbers 1, 2, 3, 4. There are the currents I1, I2, I3, I4. Okay, if the current is entering the node, we are taking it as a minus 1. If the current is leaving the node, we are taking it as a plus 1. Okay, now at node 1 the KCL equation is I1 minus I2 is 0. At second node I3 minus I4 equals to 0. At third node minus I1 minus I3 plus I4 equals to 0. At fourth node I2 equals to 0. So if I2 equals to 0, see, if these are the four equations we got. Now I2 plus I3, it is not a KCL equation, and I3 plus I4, it is also not here. So the only possibility is option B, hence option B is correct.